Hi, welcome to Math 151. My name is Nelson Pupakon. You can call me Nelson. Okay. Let us begin with our first lesson. Talk about finding the limit of a function then. Okay. So let us look at our first example. I would like to graph and fill the table of the function f of x equal to x squared multiplied to x minus 2 divided by x minus 2. Okay. Then, in order to graph this function, maybe let us start with talking about the domain of the function first, okay? So to this function right here, the domain, it will be all real number except x equal to 2, okay? The reason is when x equal to 2, then you will see that the denominator that we have is actually equal to 0. So you know that any number divided by 0 is actually undefined. So therefore, in this case, this is the domain of this function then. Okay. Then one thing about this function f right here, you will see that the numerator and the denominator, they both contain x minus 2. So in this case, if we cancel it out, then what happened? You will have x squared left. So the graph of this function f right here, it will look like x squared. However, what happened is actually when x equal to 2, you will have an open circle right there. It is open at x equal to 2 then. Because when x equal to 2, it is undefined. Okay. So in this case right here, we call this point x equal to 2, this point right here is a removable then. Okay. Then now, let's see how do we actually fill this table now. So one way to do this is we could actually use our graphing calculator TI-83 or 84 that we are using in this class, okay, to work it out this problem. Then let us bring up a calculator now, okay? Okay, so you can go to y equal to, and then input the function x squared times x minus 2 divided by x minus 2. And then you could click on zoom number 6 to graph the functions, okay? Then you will see that the function it look like x squared, right? If I graph the x squared functions. Then you will see x squared basically is on top of the function, our function f then. Okay. And then now, if you look at the table, then what is the difference between the f function that I have and x squared function is when x equal to 2, you will see an error there. Okay. So it just tell me that we have an open at the point x 2, 4. And now, how do we actually, now let us try to evaluate the table then. Okay. So how do we actually use a calculator to help us to do this? We have two ways to do this. One, you could click on second trace to bring up calculate, this menu right here. And then you could click on 1, and you could input 1.9, right? And then write down when the input 1.9, then I'll put it 3.61. When the input 1.99, then the output is 3.9601. Okay, so this is actually one way to work it out the problem. Another way to do this is here. You could click on the keystroke. Okay, again, you go to the home screen first. The keystroke is wow, this button, and then select the second menu, Y wows. Okay, and then you see function, put enter, and then you select Y1. and then you put like a function notation. Right? You put 1.999, okay, something, and then it will give you the output. Okay, so this is the idea. Okay. Okay, so then use your calculator to fill up this table. And then for 2.1, you will get 4.41, 4.04, 4.004, 001. Okay. And of course, when x equal to 2, actually it is undefined then. Okay. Now we are going to talk about the limit of a function then. So is that right here? Suppose the function f is defined for all x near a, except probably at a. If f of x is arbitrarily close to L, for all x sufficiently close to a, we write the limit of f of x as x oppose a equal to L. Okay. So this is how we define limit of a function. Okay. The symbol approach, okay, or you could say that it gets really close to a then. Then now, let us talk about the one-side limit. Okay, it said that limit of f of x has x oppose a equal to L if and only if limit of f of x oppose a from the left side, and also x approach equal to L, and the limit x approach a from the right of f of x equal to L. Okay, so this is the idea about the one-side limit. How is this work out to the problem? Okay. So right now, let's talk about has x approach 2 from the left side. Okay, so you will see that has x approach 2 from the left side, it look like that the x approach from 1.9, 1.99, and 1.999. So in this case right here, it's kind of like this. X approach 2 from the left side. Okay. And then you will see that what happened to the output that you have. The output that you have is getting closer and closer to a number 4. So in this case, we could write the limit x approach 2 from the left-hand side of the function f of x, it is equal to 4. Okay. Then now, let's talk about has x approach 2 from the right-hand side. Okay. Let's look at this. So in this case right here, you will see that x approach to 2 from the right-hand side is kind of like we get to from 2.1, 2.01, 2.001, and closer, okay? So in this case, the limit of f of x has x approach 2 from the right-hand side. Okay? And you will see that again, the number that you have is getting closer and closer to 4. Okay. Then, based on the result from the left side and the right side, right? Then we could make the decision that in this case, the limit of f of x has x approach to 2 must be equal to 4. Okay. If it is from the left and from the right, the output that you have, if they're the same number, then in this case, the limit exceeds and the limit is equal to L. So then in this case, the limit x approach to 2 from the left hand, from the right and from the left, they both equal to 4. So therefore the limit exceeds and the limit is equal to 4 then. Okay. So this is the idea about the one-side limit. So in this case, L is a finite number, meaning L must be a number, and the left-hand limit is equal to L and the right-hand limit equal to L. Then in this case right here, the limit exceed, okay? And the limit exceed and the limit of f of x has x approach a of is equal to L. Okay, this is the meaning of this. And now let us look at the following three example here. Okay. This one, and this one. These all three example, the limit exceed and the limit equal to L. Okay. The first example is actually show you that f of a equal to L. Okay. So you see that when the input is A, the output is L. Okay. So in this case right here, you will see that from the left, okay, x approach to A from the left-hand side, the output that you have is closer to L. And from the right, as x approach to A from the right-hand side, what happened? The output that you have is also getting closer and closer to L. Okay, so that's why the limit exceed and the limit equal to L. Okay. The second situation is f of A now is not equal to L, but it is equal to M. Okay. However, the limit exceed. The reason is, again, x approach A from the left side. The output that you have is getting closer and closer to L. X approach A from the right-hand side. And look at this, what happened to an output? The output is also approached to L, so therefore the limit exceed. Okay. The last situation is f of A is actually undefined. Okay. Even though f of A is undefined, but the limit exceed, the idea is the same. Has x approach A from the left-hand side, the output, okay, is getting closer to L. As x approach A from the right-hand side, the output that you have, again, is getting closer and closer to L. Okay, so therefore, those three conditions is actually show you that the limit exceed, okay, and the limit, they are equal to L then. Okay. Then now, let us look at our first example, okay? So let's see. To this example right here, I would like to talk about the limit of f of x has x approach 1, okay? Oh, I would like to figure out what this one is. Then now, let us look at this, okay? So you will see that x equal to 1 is this vertical line right here, right? Dashed line, okay? And now, to this one right here, A, when the limit x approach 1 from the right-hand side, okay? X approach 1 from the right-hand side, okay? Then what happened to the output? The output that you have is getting closer and closer to, wow, the output that I have is closer to 1. So that's why my answer here is 1. On the other hand, as x approach 1 from the right-hand side, and now look at this. The function that I have, isn't it? The function that I have is getting closer, the output is getting closer and closer to 3. So then in this case, the limit x approach 1 from the right-hand side of f of x is equal to 3 then. Now, based on the definitions, if these two numbers, they are not the same, then what happened to the limit? The limit does not exceed. Okay. Then now, the last one, what is f of 1? You will see that f of 1 is equal to 3, right? Because you have a solid dot right there. Okay. Then now, I would like you to pause the video and then try to see if you could figure out that what number 3, that means will you be able to do number 3 then? Then now, let us look at this, okay? So, limit of f of x has x approach 1 from the left-hand side. So in this case, as x approach 1 from the left-hand side, what happened? The output that I have is getting closer and closer to 2. And has x approach 1 from the right-hand side, then the output that I have, again, is getting closer and closer to 2. Then now, what happened? The limit exceed, because these two numbers, they are the same. Okay, so therefore my answer will be 2. However, in this case right here, what is f of 1? F of 1 is undefined then. So now let us continue to the next problem. Okay. You will see that the next problem is actually, I would like to sketch the functions with the given property. Okay. And then you do not need to find a formula for the function, but the domain of the function is all real numbers. Okay. Okay. So then now let's see how we actually work on this problem. Okay. So then now let us go back to calculate the previous example. Okay. Now you will see that when we actually work with the limits, okay, maybe let us look at our this example right here. Okay. Okay. What you could consider that the limit here is actually when you have 1, 1, you could consider that this is kind of like a point. Okay. You could consider that is open at the point 1, 1. Okay, so kind of like this, we have an open. Okay. However, what happened to the functions? From the left side, no matter what happened to the function will getting closer and closer to this point, open point right here, 1, 1. Okay, it could approach it like this, or approach it like this, or approach it from below. But again, eventually, the function will get to this point. Okay. Okay. And same thing with this one. Okay. You will consider that you have an open at 1, 3. Okay. You have an open at 1, 3, and then because the function is x approach 1 from the right, right? So it's approaching from the right, okay? Just connect a line from the right to connect to this one. And then now, this right here, f of 1 equal to 3, is mean that you have a solid dot at the point 1, 3 then, okay? So this is kind of like the idea, okay? And then now try to see if you could use this idea right here to help you to graph, to work on number 4 then. Okay, so then now let's see. So to this problem right here, we have couple kind of like thing that we need to remember. Okay, to this function right here, I have a point at 1, 0. I have point at 2, 4, and also I have a point at 3, 6. Okay. This one is actually telling me that I have an open at point 2, -3. And then, of course, this one tell me that I have an open at calculated 0.25, right? Okay. So then now, let's see how we actually finish the problem. First of all, when you have the graph, make sure that you put down the scale on the graph, okay? You have to understand or notice any graph without scale, meaningless. Okay, then now let us work on this now, okay? So I have 0.10, 2, 4, and 3, 6. Okay. And I have the open at 0.2, -3. Okay. And also I have open at 2, 5. Okay. So then now let's see how do we actually trace the function then. Okay. The function from the left, okay, it will go through the point 1, 0, and then to this one, it will getting closer and closer to the point, okay, 2, -3. And the function on the right, it will be again from the right. Then the function will be getting cross or touch, right? Cross the point. In this case, it will be 3, 6, and then get to the open right there. Okay. Remember, one thing about this, the function will not, okay, the function will not do this and then continue to here. If they continue connect to this right here, meaning it's not a function because it failed the vertical line test, right? So this is not allowed then. Okay. Then because the function is to all real number, then what I need is I just make it right. It's like this. Okay. Of course, some of you can do it this way, so it doesn't matter, right? We could actually do this. Okay. Yeah, that is okay too. As long as it is a function then, right? Okay. Then now let us look at our last example. Okay. Now this example is actually talk about right now we have functions. psi of 1 over x, okay? And then we would like to see if the limit of this function psi 1 over x has x approach 0, what do we have? Okay. Then now, let us start with the table then, right? That's like what they ask you to do. So I would like to create a table to evaluate the values, okay, of this. Okay. So so for x equal to 2 over pi, 2 over 3 pi, 2 over 5 pi, 2 over 7 pi, 2 over 9 pi, 2 over 11 pi. Okay. Then I would like to evaluate psi of 1 over x. Okay. Okay. Now, before I evaluate psi of 1 over x, maybe let me add a row that try to evaluate what is psi of 1 over x equal to. Then 1 over x, in this case right here, is mean that we take the reciprocal of 2 over pi. So we will get pi over 2. Right? And now, if you remember as psi functions, okay, then you will see that pi over 2, okay, oh, this one right here, it will be psi of, maybe I call this y then, okay? So when the input is pi over 2, then my output is 1. When it is a 3 pi over 2, the output that I have is -1, right? And then 5 pi over 2, 7 pi over 2, okay? Okay. So then now, if I evaluate psi of 1 over x, basically it means that I would like to evaluate psi of pi over 2, right? And then this give me 1. Then psi of 3 pi over 2, this give me -1, okay? And then you will see that the pattern, it will be 1, -1, 1, -1, okay? Then for B, you will see that the pattern basically is 1, -1, 1, -1. So the values oscillate between 1 and -1. If you graph it out, the function y equal to psi of 1 over x, you will see that here, okay, or if you look back to the table, okay, do you see that the number that you have 2 over pi, 2 over 3 pi, 2 over 5 pi, the number x is opposed 0 then, right? The x is getting closer and closer to 0. Okay. Then In this case right here, as x approach 0, the graph of y equal to sine of 1 over x oscillate between 1 and -1. Infinitely. So then in this case, what do we conclude about the limit then? Then we could actually say that since the values of f of x or y equal to sine of 1 over x do not approach a fixed number, as x approach zero, the limit x approach 0 of sine 1 over x does not exceed them. Okay, so then to this lesson right here is actually is we first introduce the idea about the limit of a functions. Okay, so thank you.